Oh, hi. Seems that I'm live. I thought my computer had frozen and given up, but looks like it hasn't. Excellent. Well, welcome back to the stream. I'm Junchan, and today we are streaming with our new schedule. So I suppose we are in our new week. We are on the 23rd, and we shall maintain that new schedule until the 29th. And what are we going to do? Well, we're going to do some more Haskell because, I want to go back to this NBody CUDA, or let's rather say accelerate, like using accelerate and trying to understand what's up. And so, yeah, that's awesome. Last time, actually, I'm modifying the log from a couple of days ago, so that's not huge problem, but let's copy that and let's go fish for our NBody problem log, which was quite a while ago, because we had all this graphics card on next troubleshooting things and whatnot. So, and I think we got pretty far, but to the point where I think, if I remember correctly, we had some kind of sec fault, and we were trying to roll back the NVIDIA driver to a state where we'd have the correct pairing of the driver code, the accelerate low-level CUDA Haskell side of drivers, and our graphics card. So let's see where we get. But before we do that, just want to spend a little bit of time. Basically, I suppose you could say maybe bragging. I don't know if it's bragging. It's probably not bragging. It's just it's more like gratefulness, gratitude. That's how it's called. Yeah, I get to spend a little bit of time with one of the people that I suppose I get well, it's saying that I get inspiration from Sir Edward Kmet is maybe a bit strong, because I did get inspiration not maybe from so much from his code than from the fact that he started streaming Haskell on Twitch and then archive some of that on YouTube, and just having access to his live thought process, how he thought about problems and the type of problems that he investigated. Apart from his conference talks, that was a really useful window into what I would consider at this point to still be, for me, like very much something that I'm trying to travel towards, but is still at this point out of my reach. The type of algorithmic thinking, the type of thinking about how things are mapped onto the hardware, the relevance of the programming tools that we use to the more recent advances in hardware. I'm referring to, for instance, the ability to do SIMD style execution on programs, which allow to make full use of very wide CPU registers and accelerate programs based on that. So definitely one of my goals in looking at accelerate is to just slowly work my way up to understanding some of the more advanced stuff that Ed is working on. And I was really lucky to have been lurking on some of his Discord and just got a bit of chance to have him to chat with him and have him explain to me a little bit some of the more recent stuff that he's been working on. And that is mostly related to the distributive package. Let's see, I'm going to put it up. Because it seems that thanks to a gentleman called Aaron, let's see, which Aaron would that be? I'm not sure whether Aaron actually directly contributed to the code base at this point. But apparently Aaron came up with some more advanced representation of the distributive type class and which connects to the representable type class in a way that, well, so yeah, in a way that makes everything more usable and more automated, meaning you can get instances like, for instance, in this example for V3 by just deriving from, in particular, some of the like the representable type class can be derived, but also what is it? Well, distributive apparently allows to gain a number of other type classes automatically. So this is, as I mentioned before, a bit above my pay grade. Oh, Aaron Vargo, there it is. There he is. So I'm actually even barely understanding what representable is for. I think I get it. I think it's mainly used to switch between a representation that might be sort of clear from a computational standpoint, meaning it's like a function, and you can see that it's a function, to a representation that actually highlights maybe the more data structure side of given function in a way that allows to do more efficient have more efficient runtime properties by, for instance, taking advantage of memorization, and in some cases also taking advantage of sharing for persistent data structures. So all of this mumbo jumbo I have some intuition about, but not anything very concrete yet. So I'm inching my way towards understanding that. And so that means that I'm not, despite Mr. Kmet's explanation, I'm not able to grok all of the subtleties because I haven't spent much time with the older version of representable. So that makes me, and understanding its applications. So that it means that my understanding of the novelty is also slightly fuzzy, right? And I'm sure Ed will do a more public talk about this. He's probably refining this and testing it on people in his Discord these days, which I think is a great way to make it tighter. I wasn't able to contribute much to that, but what I understand, and I'm not sure whether that's correct or not, but I think distributive basically, because it allows you to basically, let's see, is there an example for that? It's basically something that allows you to go from a FGA to a GFA, so to distribute functors in some sense, or commute functors, if you look at them in the functor category, I suppose, in such a way that it allows you to access some optimizations that you might otherwise not have. And so there's a lot of ways in which all of this is also tied to ensuring that Fusion still works for transforming lazy data structure into tight loops and things like that. But also there's a dimension that I think is opened up by this representation, which is that it relies on this concept of an F functor. And it seems that, and it also relies on changing what I think in the current representable is called rep, and I think in some of the original representable was called key, and is now called log, and the choice of log, I think, gives you a number of different properties you would like. I'm not even sure whether that's actually a correct or solid interpretation here. But distribute, right, we'll take a WF and transform it into VFW. And I think a lot of the magic, from what I understand, is that it comes from basically transforming the distributive the distributive I guess isomorphism, or maybe it's a natural isomorphism between WF and FW by making W a higher kinded data type so that it actually takes a functor. And doing that, it seems like brings a whole bunch of interesting properties, including the fact that you can define now distributive for higher kinded data types themselves, and that you can do that using a functor rather than an FF functor. With 3 Fs instead of 2. So you don't have to keep on trying to redefine your type classes and your functions to work in higher and higher levels. You actually, by defining a single layer that is higher kinded, you can define abstraction towers as high as you would like. So I'm not sure I understand yet exactly, apart from the general statement of the fact that, having this ability to commute an F and a W here usually allows you to choose operations that will go fast and do things like maybe your F and your W, maybe your W will actually maybe chunk your data in some ways, put it in a more matrix-like or a square functor of a container that will allow you to make it fit into your memory width or your CPU processing width, and that this ability to permute things mean that you can sort of allow your libraries to pick up the right representation based on the data type that you have, or rather the actual hardware that you have running underneath. So I think it allows to do other things, but I think that's one of the things that Ed is eyeing towards, and this ability to also have a kind of a hardware abstraction layer by being able to instantiate a library like linear, like vector computations, to a particular CPU architecture that will completely optimize and take full advantage of the parallelism that you can get with those architectures. So I think that's one of the aspects. And then maybe some of the other aspects is to actually also allow to, like I think in connection with his work on relational programming and logic programming with Guanxi and so on, I think that would allow him to get a lot of speed ups and take full advantage of this machinery all the way up to much more advanced algorithm than just linear programming or statistics or things like that. He has some implementations of like things like propagators, for instance, that because they can be formulated in ways that are pretty mathematical, I think having this ability to distribute is going to allow to gain a lot of potential speed ups. And I think also a number of the talk that he gave on kind of scatter gather style, like the radix sort algorithm, like things, I think that was in his cache oblivious data structure talk. I think all of these data structure also benefit from the ability to just define instances for free by deriving things. And there's something I don't quite get, and maybe it could be that I'm seeing this as solving all the problems, whereas actually only solved a few of the ones that I've listed. But it could be that some of this hardware architecture, optimizing for hardware architecture, it could be that it's dependent on the choice of some of the inner functors that you want to distribute over, maybe. I don't know. I'm just trying it out. It might be that I'm not thinking correctly at this point, but I'm looking forward to understand more about all of this. And so that made me look at JST generics, because I knew a bit of generics SOP, but not yet JST generics. And a lot of the machinery to derive everything automatically is obviously based on generics. I looked at this old formulation for representable from representable functors. I think that's not used at all anymore. I think it's more like the distributive variant or from the distributive package that's used these days, but it used to have this key. That used to be the thing for representable, and representable is something that you can index and tabulate, and one allows you to basically go from a function, so something that's isomorphic from the function from X, to a representation that actually has your data, has your function tabulated like a lookup table. That's the habitual example given, except that instead of a lookup table in a lazy context, you can actually build your lookup table as you go along by memorizing the execution of your function and putting that into your indexed functor. And your key, I think, then is that data structure that can hold the memorized version of the function you're trying to create a representable instance for, or anything really. It doesn't have to be a function. And I also looked, so it seems like one of the examples that keeps popping up also when Ed's talking about this is the Moore machines, and I haven't seen anyone drag him in that direction yet, but I'm really interested in that because, well, actually there's a bunch of stuff that I discovered by going deeper there. One is that well, okay, let's talk about this. I found this because it talks about representable machines, and it goes quite deep into doing some categorical mathematical transformations based on these Moore machines. What's a Moore machine? It's just like it's not wrong, I think, to say that it's a form of stream. It's actually, I think, technically you could maybe say that it's isomorphic to stream. You could say it's isomorphic maybe to even a coroutine. You could say it's not exactly maybe isomorphic to a melee machine, but it's in the same ballpark. It's just a small variation, but I suppose in the way that free and co-free are. In the sense that I think a Moore machine is ready to go. So it's basically a Moore machine needs an A to move forward and holds a B. And so any given Moore machine at any given point holds the current B and then waits for an A to get the next machine that might hold a different B, but will also wait for the next A that will pop up to the next state. So it's kind of this iterative structure that just waits for an A and then keeps moving on, and B, you could say, hold its kind of current state, I suppose you could say, so which make this kind of comonadic, which is also, and it's also isomorphic to co-free, where F is the function from A. And so, well, function from A, we were just talking about function from X for representable. So that's kind of where this goes. Even further by unpacking co-free in a way that I hadn't seen before. I mean, I think I skimmed over this once, but now I actually understand more. I'm sure, in a year when I reread it, I'll probably understand even more. That's the beauty of this field, I think, for me at least. It's like it has depth. So he uses he unpacks co-free as with more fundamental combinators like fixed point. So exposing that co-free is actually fix of compose of a product. So now you're getting like really, really sort of fundamental building blocks, fix being sort of the essence of iteration or recursion, comma is the product, and then compose is the essence of category theory. And then just using recursion, composition, and products there, you get co-free. So I think there was some article that I read somewhere that was talking about this is like functors in kit or data structures as a kit. And it's a bit like that. It's like, you at some point you see all your data structures, your algebraic data types as sort of combinations of products and sum. Then at some point you understand that, products and sum and functions. And then you can throw in, actually recursion is actually also useful to have in there. And then you kind of have your whole kit and you can sort of define the whole world from there. In fact, you can define the whole word just from function. That's going to church the lambda calculus. But all of these building blocks are in fact the y fixes the y combinator, and all of these other things, const and identity, are these other combinators. So all of this is forms the mathematical basis for computer science, I suppose you could say, or even computation. So he uses that co-free, and so here we're departing also from my comfort zone, because I intuit that you can express co-free in terms of a fix, but this is not exactly quite yet completely familiar to me. Actually, if I look a little bit more at it now, I've started to getting familiar with it, because I see that it is this idea of you compose f together with something, so that whole thing is going to be repeated. It is going to be recursed over, right? So we're going to have this construct repeated over and over again. And so what is going to be repeated? Well, f composed together with this thing. And so f is basically means that for each iteration you're going to have a f that wraps the thing, and that's the f that wraps the co-free that we can see in this definition. But apart from having an f that wraps the co-free, here co-free has an a and that f that wraps the co-free. So that's exactly what that comma a in the other, as the other argument of the compose. Is compose not a function? Compose is a tensor operation, let's call it, but technically it's a tensor. So composing comma a means composing the product with a, and this is really a product type. It's a and this thing. So we exploded this into its more fundamental, like, not even, we're in some sense we're taking a step back from Haskell syntax to put it back down into mathematical syntax, where we have fixed, compose, and products, and all of these things are more grounded in mathematics, and they're more atomic, they're more fundamental building blocks. And then with this co-free, I'm getting way too much into the depth, but I suppose I'm what do you say, I'm doing spaced repetition, because I looked at this on Sunday after talking to Ed, and now I'm watching it again, so I suppose it will stick. Spaced repetition makes me think about this talk. Yeah, go check out this talk, Stop Treading Water. This is Ed talking about his way of learning about things, and very worth reading, watching at any given moment in time. Really is kind of a meta perspective on how he knows what he knows, and how he continues working on both a set of problems and a set of solutions that he's cultivating. Very much worth really important points in there about learning and intentionality in a lot of ways. So then so he finds this way to unpack the definition of a Moore machine in a way that allows him then to turn around and see that it can be defined in terms of a representable functor and its rep instance. So that's the key or the log these days. And then he gives some example. Well, he explained how to step into things, and gives in passing the fact that a Moore machine is a profunctor. All of this has very deep implications. Actually, I'm going to go off a little bit and talk about some of the stuff that I thought, because this actually turns out, and that is something that totally knocked me off my feet. It goes further down to basically explain that Oh well, yeah. Right. This is why I installed Chrome. I remember now. So let's fire up Chrome so that you can see what I did there. What I did is I made some annotations using a hypothesis. So a Moore machine. So he spits out, he cooks up 3 different possible alternate representations for Moore machine. So not just the fixed base one, the representable one, but also one that's based on even a higher concept, the concept of an adjunction. And then he points out that a Moore machine is pairing up some comonad with a function that gives a monadic action. So I think right, because f after G is a comonad. So that's f after G, yeah. So that's a comonad, and that's a function that gives back a monad because G after F is a monad that comes from the adjunction. And this is something that I've been exploring because I've been exploring comonadic UIs, and that's, well, it's exactly the workhorse of comonadic UIs, this pairing between a monad and a comonad, and specifically free and co-free, and specifically with the insight from Phil Freeman is that comonads can be regarded as spaces, and if you regard comonads as spaces, then I like to think of monads as actions taken in that space, like if space was actual space, and that if an action was an actual movement action inside physical space, for instance. But of course you can abstract that to any space, and usually programming it's a state space, and monadic action is actually an action from state to state. That's the common action. But there's something that popped up here and that I hadn't really considered yet, is that the Moore machine is actually what makes this go. You could, on one hand, you could say maybe that this pairing is some of the essence of this concept of comonadic UIs, and the pairing of something more space-like and something maybe more navigation-like or action-like. But I think that this deepens my understanding and my intuition more, is that no, it's not sufficient. Yeah, the pairing is fine, but this is a specific way to pair them. It's a kind of like it's the motor, the engine that makes this pairing move forward in time. And then that starts getting a bit metaphysical for me, because you could say that, in fact, the comonad defines space, but without necessarily implying time yet. And that the spaces of action, or monadic action, the monadic side of the equation, defines maybe intention, some form of active walking through or agency within a particular spatial context. But again, it's this agency at this point, it could be seen as beyond time, meaning you have all possible actions, and in the comonadic space you have all possible spaces, all possible position in the space, or all possible states in the space. So especially if you start kind of considering these as multidimensional, then it's really interesting. You have all of these spaces that are open, but that are in some sense, they're full of, they can be navigated in time in any particular way, right? Except that they will be the way in which you will move through one and the other is completely paired. So it's kind of the inseparable in the way that they will pair. And the Moore machine, in that sense, becomes the things that makes it go. It's the thing that then makes it, that binds it in time, that binds a particular action to a particular space, and then says, okay, if you give me that particular action, that particular place or position in the state space, then I will move you forward in time to some other space. And so then you could say that the Moore machine is the thing that all of a sudden collapses this hyper-dimensional universes of monadic actions and comonadic spaces into a thing that starts moving at a particular moment, and that the Moore machine and its current state represents now, and that obviously you can project you can simulate the progression of the Moore machine in time by all of the degrees of freedom seen from both angles of all the monadic degrees of freedom and the comonadic degrees of freedom, which are actually isomorphic. And that stuff is completely blowing my mind because it's very metaphysical for me. Yeah. So I love that stuff. It's deep, I think. Deep in its philosophical implications and its implications about what's space, agency, time, and possibilities, all of that means. So lots to think about here. And let's move back to some of this. So foldable, that's when I moved into hypothesis. And this is actually connected to when we were searching about Ed's graph package on Saturday. So that's it for this big parenthesis, but I wanted to capture it since it made me really happy to get a chance to dig deeper and to continue being inspired by Ed. All right, so let's move back into our NBody problem, and let's see where we were. Here, this seems like maybe we didn't update all of that, or did we download a more recent? All of that stuff, I think we can finally kind of forget that it ever happened. All of our Windows previous attempt. And I think we won't do, we maybe we'll get back at some point into this, but right now I'm going to remove it from my mind, including what I suppose I had, thought of as a blog post I could contribute. I know I have to do that, but we'll see at some later point. Okay, and we did switch to we switched to NixOS instead of Ubuntu, and we did switch. We did switch, and we were about to run the NBody example in the GPU, which was always our goal. And for that, we had last time to revert to a compatible 10.2 CUDA driver. So let's just check that this is still sane. And by doing, I suppose, NVIDIA SMI. And we see we have CUDA version 10.2. So let's move into the shared workspace and NBody and the accelerate example. And then I think we need to Nix develop into this because we had flakified our the accelerate examples with Haskell.nix and the stuff that we've started to use elsewhere. And we've also optimized what are the extra dependencies that we patched in, specifically the Vulkan beta drivers, for instance. So in theory, one thing that I haven't added into this particular project yet is an indication that we are in a flake. So we have the nixconfig bash prompt right here. So we are going to also add it to our NBody to our NBody problem repo. If I can copy paste properly, which obviously I can't because it's hard. And let's do it like the old people we are. That's unfair. There's old people that are artists with VI and other less clicky pointy interfaces, and just not. Okay. So with this, we should be also able to check that Vulkan still works with 10.2, and I think that that shouldn't be an issue. Shouldn't be an issue. Well, we see we have our prompt, so that's good, and Vulkan works. However, I think if we I think we had already kebab built. Yes, indeed. Fail to build. Oh, fair to look at it. So maybe not quite solved in the way that I thought then, but maybe that's good, because if that's the case, then when we had run the executable before, then it could be that we were in fact hooked to a previous build and things weren't properly rebuilt. So let's make sure that we have CUDA here, and then because we use the stack version of things, right? I mean, we use Project Prime, I think, as the project builder here, but we don't use a compiler Nix name, so we're using the stack file. And I don't need Docker extension, thank you. And is that how we passed the flags? Yeah, I think maybe that ended up being how we passed the flag. Okay, we'll want to test all this on the CPU as well, because we have a monster of a CPU, so we might as well, right? Remind you, I have 56 cores and actual 28 physical cores, so it'll be fun to test on that. It might actually be even faster than our GPU. And there's an LLVM. There should be an LLVM backend that takes advantage of that. Okay. So what are we doing? We've reactivated the CUDA override inside the flake.nix, so the overlay. So hopefully that should install what's needed, and then we can kebab build. Although I suppose I'm kebab building, but I should be stack building. Maybe that's the other thing. Because yeah, that's probably the thing, in fact. So hold on, let's backtrack here. I'm going to need to remember that I'm using two different ways to do things here, which is not the best, but well, it's only the two things, right? Okay, so stack build might actually work, because stack because Haskell.nix is going to fill in or make the system dependency available to either stack or Cabal through different ways. I think it makes it available in Cabal through patching the GHC package database, and stack I'm not sure how it's done, but whatever the equivalent is. So yeah, so So it makes sense that Cabal building, even though in theory could work, in this case just misses some system dependencies because they're not made available by Haskell.mix. Okay, so yeah, in all honesty, it's also, are we building this CUDA 10.2 as well? Stack. We're not building the CUDA 10.2 that's next to us. We're building the system one, the Hackage one. This one I think needed fixing mostly for Windows. Yeah. Oh, so that's not. So hold on. Cabal file info not found for CUDA 10.2. Updating. And then based on that, it gets GHC again. That's a bit strange. You're not going to rebuild GHC, are you? Okay, that's something that happens way too often with Nix, at least Haskell.Nix, but to be fair, with Nix in general, it rebuilds the world, whereas Billy, it should have the world in cache. It should also, specifically because it shouldn't have garbage collected, because I have in my NixOS configuration.nix, I actually have keep thingies, keep outputs, keep derivations, which is supposed to prevent garbage collection of Nix shell. Well, it says in DRAM, but I suppose it prevents garbage collection everywhere, right? It should. So yeah, that's not great. I'm not too happy with that, because now it looks like it's actually rebuilding. It's really rebuilding base. So we can't have that. So let's do something. This was for stack 8.10, which is now a LTS 1710, I think. So let's go check that. And if we're going to rebuild the world, then at least let's get something more recent, because it's likely to be in the cache. Is basically my thinking here. 17.7. So let's move to 17.7. Let's see if there's any visible differences between the. Well, actually, let's leave this to computers. Let's select for compare, and then let's compare with selected. Aha. So apparently we also need a few additional things. Cabal 3 is a broken POS. Oh. I was thinking that was a technical term. Okay, FCW2 is your. So hold on, which. I think. Oh, okay. It's 8.8 that we're using. So okay, let's compare 8.8 instead with 8.10. Here, so that's just that extra flag. So let's just not put the extra flag and see whether it works or not, because usually these things get fixed. And let's hope it's going to allow us to download the whole world instead of recompiling the whole world. Oh, that's too recent for Haskell.nix, or yeah, stackage.nix is actually Haskell.nix, so it is too recent. That's fine, we can start going down slowly. I see. Could be we need to upgrade. Oh, this is using master here. So okay, we test this. If it doesn't work, we go check out Haskell stackage.nix, I suppose. It does work. Okay. So only two minor revisions below current LTS. It's not too bad. And so that means that still some .cabal Haskell package thing being built. That's the, yeah, I think that's all of the tooling maybe that's working to. I think this is this IFD thing, this these derivations that are built early on, and we're querying a whole bunch of stuff and fetching a whole bunch of stuff, including the base compat stuff that we were building earlier on. So yeah, indeed the cache holds more. And that's going to definitely make things go faster for us. So I can drink a bit. Okay, so far, some system. But I suppose that's... I suppose it's good to be on a GHC 8.10 instead of 8.8. C++ 11. Do you remember when I was downloading versions of GHC for Windows? Bye-bye. Okay, so some stuff is being built. So, okay, let's go take a look at the source code. Let's see the examples and NBody. Because last time I think that to compile, we had to comment out all of our solver. Because we also had added an additional parameter to the original calc accels, which is this XR. But I think, but we didn't update the calc accel. And so how come I also didn't? So did I just transform int into an XR? It looks like maybe that's what I did. This is still called size, but it's not going to be trivial to get back straight into it because I had a bunch of stuff open to try and deal with that. Let's open a new window with all the new stuff. So I think I was relying on this Barnes Hut algorithm. It wasn't this. might be this. It was a well-written. Oh, cool. That's even that looks even better than the other one. Check this out. Yeah, very nice. Huh. Very cool. Love that. You can use PureScript to do things like that. And maybe it was this one. No. I don't remember how we picked it. But yeah, I see Quad 3, and it reminds me that most of what we saw was 2D. Yeah, there was this. There was the one program with the GHC version of this array acceleration thing. How is this called already? This branch that never got merged, that Simon Peyton Jones worked on for array computations. Nested data parallelism was one of the goals. I think it never got there. Yeah, DPH, data parallel Haskell. And so there is a data parallel Haskell implementation of the Barnes-Hutt algorithm. There just isn't a accelerate version. And implementations. Ah, that's cool. Didn't know about that one. And there was even a video, which is kind of interesting. And yeah, I think that's the one. And yeah, that's the one. I want to check this one out. Just getting a little bit of inspiration, hoping that we'll see some of that soon. Nice. Has the compilation has failed because of some template Haskell thing? What is that? Source data atomic? Is that's not in this package? Which accelerate lib accelerate? Oh, maybe it is in this package. Lib. Lib data array accelerate. Source data array accelerate type. Right, yeah, we are going to need more info than this, of course. And how do we do this already? There was a Nix log something, and I wish this was simpler. Yeah, I think it's Nix store Is it on the Nick store? Ah, okay, I have to search for it. Nix develop how to see whole log. Print build log. It's okay. It's supposed to be a common thing, so but I don't see it here. But maybe it goes here. Yeah, it does. Okay, good. Okay, and so where is the error? A is out of scope. Is that the one? Oh, hold on. We're still building. Ah, no, here. Okay, error. User error. No location info. Accelerate, leave, accelerate. Compiler main, HAC main. Yeah, I doubt we have access to that. Yeah, of course, I'm looking at accelerate examples here, and this is in accelerate, not accelerate examples, of course. So do you think it could be linked to this? I suppose it's worth a shot. But let's also go and check out what it's going to be hard. And also no location error. The template Haskell problem. Yeah, it's going to be hard to troubleshoot. Yeah. And same error. Can we trust that this is here? Is this in th extra? Let's go check out the accelerate repo, see if there's been any recent commits. 21 days ago. NoFib built locally. Hold on, wasn't this connected to NoFib? Maybe not. There's some upgrade to GXC10.4. So all of this is fairly recent. So yeah, I need to switch to the master branch for accelerate. So how do we do that? Can we do it in stack? We can, right? So stack. Okay, let's look at Haskell.mix stack. That's not the one. That's the one, and we want the docs, and we want to handle Git repositories in projects, and we want to do something like so. I suppose like so. And we'll probably want to go straight to the last commit. So I shouldn't have done that. And accelerate. Okay. And then accelerate FFT, is that a different folder? Let's look at, I think the Kabal file. Accelerate. Some flags and the library. I think it looks like it might be this single one. So right, yeah, FFT is a different one. So let's start with that. See how it goes. Okay. Good. Damn, not good. Same error. Exactly the same place. And stack.yaml. Shouldn't need to change anything here. Let's go check out the issues. Well, let's look at the closed issues. I could be wrong here. I mean, I think it feels like it's template Haskell related. Maybe? I'm saying this because this 40th module here has some template Haskell in it, and it's the one that gets bundled in this error there, but it could be the one just before. So I suppose we should clone accelerate and then go investigate in there. It was due to happen anytime anyway. At some point, I mean, you know. Oh, really? Okay. And then we shall say that we depend on this accelerate, and we shall try to build it. Stack as LTS 17.4. Something we could try, I suppose. We'll need a flake as well, so let's get ready for that. And where are we? Still receiving. Wow, it's going to be a deep one. Let's get depth one. Whoopsie. And let's add this Q, and then let's add our flake.next. And I don't necessarily think we need a default package, do we? We need to add flake.next. You don't, yeah, we need to copy stack 810 to stack YAML and add that. We kind of do actually want that, otherwise I think it's not going to be picked up by Nix develop. So the missing stack.yaml made Haskell Nix, since we use this generic project prime, if there's no stack.yaml, it thinks it's a Cabal project, and then it needs the compiler name. So that's a good way to know. I suppose I could have done project file name stack 810. And then I wouldn't have had to commit stack. That would be, why are you fetching 884? $17.4 shouldn't be 884. Is it the bootstrap thing? You're telling me you don't have all of this in cache? No, it's basically, it is telling me that it doesn't have all of this in cache. Oh boy, okay, LTS 17.5, so that's a really small cache. I don't like that. Crypto hash. Okay, I think I'm not entirely sure it's building only what we need. Let's hope so. It's hard to see with this mode. Okay, so was around here, right, that the error was showing up. What's that? .hs file. Oh, it looks like some kind of template file. Oh. Oh. Yeah, I think I've seen that before. Yeah, it is. I think it's... Isn't it like used for an init? Oh, isn't that the... Actually, that's the format for... yeah, right. That's the format to start a new Accelerate project, actually, isn't it? I think it might be. Yeah, yeah. Oh, wow. It's a template for Cabal, I think. That's the syntax, and it will create all this file for you if you do Cabal init and then provide a link to this file. And then the name of your project, I think. Cool. Junctions, Cabal. I fear like we're rebuilding the world. I never quite know. I did copy paste this. Yeah, I did copy paste it, but I didn't copy the flake.log. So then that would explain why it's actually rebuilding everything, possibly. Huh. Yeah, I say that, but I did modify the stack.yaml LTS version. So how would that work actually? Not sure. It's on. Wait, it really feels like we're rebuilding the world, huh? I also feel like I subliminally see some GHC 884 stuff showing up here. I hope that that's not the case. HNIX, huh? All that stuff's super low level. Actually, let's see whether I actually do see 884. It does matter. Yeah, I do see 884. I don't understand why. If you pick stack, then you should be using the resolver. Yeah, I don't understand what's happening here. Still something about this configuration that I clearly don't get. Could be a pinning thing. Meaning I might need to pin a particular Haskell.next version and update it manually instead of relying on the log file. But that wouldn't explain why in this case I think it's rebootstrapping GHC, and it's even going to be on its way. It's on its way to build GHC 8.10, which feels completely wrong. Or is it that I simply don't have the Haskell.nix cache set up properly? I'm pretty sure I do, but it's worth a check. Yeah, I do. In fact, I have Hydra IOHK and IOHK cachex as well. Let's double check that stackage LTS 17.5 is GHC 8.10.4. Yeah, it is. So there's no reason that we would miss the cache, but it looks like we do. Which means we end up having to be rebuilding on stream instead of programming. Really don't get that. We can actually do Nix develop here and see what our error is, and from building from source, except that yeah, I need to revert back to the proper remote checkout. It should already be in cache, right? Is there a Nix develop dry run? No. Okay, yeah, it's failing. Okay, so let's see. Source language Haskell th extras. Language Haskell extras. Okay. Obviously, very hard to troubleshoot, right? No location info. Pattern match failure in do notation. There is no do in here. So possibly it means that it is actually in data array accelerate type. And then we just need to find the do, and so maybe something that's used that uses the yeah, I think if we use the, I mean, we have to wait for this. Yeah, look at this. I think it is. I think I saw it was building GC 810 now. I saw some GC 810 related things. 810. Okay, right. 810. Yeah, see? This is now using 810. So I suppose we finished bootstrapping and we're now using 810. I really don't get that. But yeah, and we did get some stuff from cache, but number of stuff that gets built is pretty high. But Comonad parse applicative, that sounds like that would be stuff that are used by Accelerate and its dependencies rather than Haskell itself. So that's good. Okay. Oh, CMD vector types as well. Interesting. Pam 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 pam. Yeah, I mean, how would we even find something in here? And it doesn't make sense. We need to wait. Let's compile with -L again. See whether we can gather a little bit more context. That's it really, huh? There really isn't any context that can be seen. Those are the configure flags. Could there be something in here? You see boot. Package conft. We are one LTS further, but we use the same GHC. But maybe the template Haskell is different. I mean, if it is the template Haskell, it could very well be this that we can't compile. It looks like it's rebuilding the world again, but at the same time, it looks like it has 70 to go. For some reason, it's doing HNIX things forever. Yeah, and distribution, like it is recompiling Cabal. That's really unnerving. I don't understand why it's rebuilding stuff all the time. ci.nix would be the source of truth. Those would be the Cabal things. Oh, does it not build any stackage things then? That's what's happening. That's built for Darwin. YAML and lens, those feels like userland things. Wow, that's very specific. 2021 or 2012 to be the most recent one. Specific LLVM version. I suppose that doesn't impact accelerate itself, which I assume has its own way of using the LLVM backend. But A10 is on LLVM 9, which I think is the one we are using here. Okay. Package docs and doc tests. Nothing special in here. The documentation. What's Icebox? Sounds like maybe things that have been removed and not supported anymore. And some C bits. Optimized for cache lines. So I don't know how baked in this is, but that's one of the assumptions I suppose that more modern architectures challenge, that have wider, I think, wider cache lines. Those probably try to map to single assembly instructions. Why would option parsing be in C? Yeah, it looks like we're just recompiling Nix tools. What? This is so painful. Layout of command line option bit failed. Strange. But I suppose there's no executable, so yeah, how do you pass flag to the library? Or maybe the command line option for something else. It's not executable here, right? Nope. Only the library. Some tests. Yeah, that's one of the last ones, which I suppose is why it gets like 40. It gets 40 out of 107 though. Yeah, it seems like there's really a lot of modules. I don't think these are the same flags that we talk about here. They're the cabal flags. Although these look like they are though. Skid. Following flags control phases of the compiler. Ah, right, okay. Yeah, because accelerate is a compiler in a sense. It just takes a subset of a Haskell and knows how to use that LVM to compile it to down to lower level assembly. So these minus F's and minus D's, are they all here then? Yeah, F and D's. They are. So maybe then it's in C because it's part of the interface to an LVM, or maybe the lowest common denominator for the different accelerate backends. Oh, no, I'm not in the right place. Yeah, we get more stuff to compile. Moving goalposts. Kryptonite though. I think that's good. Let's really see Kryptonite being compiled simultaneously with accelerate here. So that's good. We should see accelerate soon, I think. Hedgehog is a property testing library, like Quick Check, but more modern. I don't exactly know what it does better than Quick Check off the top of my head. Representation. Oh, there's an interpreter. slash. That's just an example. Backend. I see. Right. Okay. We just have our development environment right now. We haven't started building. What? Why would stack tell me something about Enix related? Oh, it uses stack, but hold on. Okay, I'm confused now. Is it the case that it uses stack and then we actually use Cabal, and I've been wrong earlier in my earlier statement? Well, let's see what Cabal build does. It could be because stack brings up pins the dependencies, which in this case are none. Yeah, it's compiling. Let's see how far is it gonna go. And should I have compiled with Cabal build here instead of? Oh, but I can't, right? It's in the dependencies that it doesn't work. Okay, good. We have the same error. At least we know that, and it seems like it's really at this type level that it happens. So maybe we can get more verbose now. And indeed we can, but what is this? It's actually in the compiler. It looks like maybe it's the formerly known as HAC main. So could it be a system dependency that's screwed up? Autogen. Anything we can see in the dist folder? We couldn't see anything when we pattern match for this, right? When we googled this, I don't think there is something here. We didn't follow that. Pattern match failure into expression at blah. Yeah. But now you're telling me, okay, I suppose we have to go look at GHC code. I think that might be the first time I do. So, hey, there's a first for everything. That maybe will give us some insight. But it's kind of weird, right? How we have to do that. Why do we have to do that? Compiler. Oh boy. Main, HAC main. There's no main here. Damn, the GitLab search is, I think, much better. That's actually a pretty good argument to switch to GitLab. Compiler main, HAC main. Hello. The right branch and all that, and 1903. Let's go down to 1903. Okay, maybe it was actually, is that the line number? There is a do expression right there. There is one here as well, though. Reading interfaces and desugaring converting to bytecode. Core exp. So, but okay, we need to check out for pattern matching. I don't see pattern matching so much here. Yeah, to be honest, I don't see much here either. There is quite a bit here, though. There's this parse thing with location. I suppose the fact that we don't have a location. Is there some CI in this? And what transformers? I mean, the commit list, there seems to be things about upgrading to JC 10.4, but if that's the only thing that was done, and this is not CI'd, was this committed directly to master? Oh, and there's no CI on this? I suppose master does get CI'd. And on Windows, apparently. And a 10. 810 though. You're kidding me, this is all happening on Windows? CI Linux. A 10.4. I suppose we could try without Nix. Do I have stack install? I do. So in theory, and do I have a GHC here? I think I installed a GHC in fact. And I didn't install a 10.4. So I could just stack build here. But this is weird. I could also just kebab build here, in fact. Stuck in Nix shell. You think you're in Nix shell now? There's some strange interaction between I mean, maybe Haskell.nix just doesn't build this code properly for some reason. Might be using some esoteric things. What does it say? It say that maybe I could also kebab build here, possibly. I haven't installed the system dependency system-wide, but I suppose I could do that too. It's a bit sort of wonky from a Nix perspective, but yeah, I wonder what's going to happen. I think CUDA is going to choke on CUDA basically here, so it's not even going to get to accelerate. But here it might work, in which case well, in which case you would tell us something about a problem with Haskell.nix, clearly. Apart from the fact that it's very unruly with its constant rebuild of GHC. Bad match failure here. Holy moly, it has gone further. So it does teach us something. Well, I suppose we have something that feels like a reproducible environment for that failure, though. So maybe that's good. Maybe we can contribute back at least an issue, but we'll do that next time. And And this is not going to complete because we won't have the CUDA tools. But I suppose we could just install the CUDA tools and then try and build this. Because wouldn't it be nice to close with something that compiles all the way? Let's look at the Haskell.mix. The Haskell.mix GitHub, and whether there's any issues related to what we're finding. Cleaning. Oh. That's very serious. Workaround worked. Okay. Right. Yeah. Okay. I suppose we can expect that to occur indeed. So, could it be because of the Cabal version? Oh, I mean the accelerate examples here. Yeah, so we know that's not going to work, so it's still going right here. Okay. But I suppose, yeah, no, I suppose it's not going to work because it's still going to fail. Can we enter the shell even if there's a build failure? Doesn't seem like it. Store the build environment in the profile. It built. So that doesn't necessarily, I mean, it does help us because we can try and do the same thing. We can GC version and Cabal version. We can Nix develop, and here we can Cabal version. Could be the problem, huh? Could be the fact that Cabal 3.4 is not where we want. And Cabal 3 is a broken thingy. Could that be connected then? So shall we try and downgrade to 3200 here? And we want to downgrade, I suppose. Well, I suppose we could try here first, because that might be a more surgical thing. And then we try, we might need to clean. So here I'm only changing something in the dev shell. It seems like it's only going to get the Cabal executable. So that I think is all right. So I wonder if it's a known Cabal bug. .3.4 was released only about a month ago. It's building Cabal. Never mixes, bootstrap. I mean, it felt a bit like an interaction between Cabal and GHC, but I suppose that doesn't say much. I don't know what Cabal's job is. When it comes to something that could touch the code that we saw here. If that's the correct location, you know, because I mean, it did feel like probably was, but I suppose we could maybe go back to 8.8.4. Let's see if there was a 1903, because maybe there's a... No, there wasn't a 1903 at that time. It's only the dev shell, so yeah, that's interesting. If it's only in the dev shell, then if we specify a default package, then how does default package get built? It will need Cabal, right? Still some things I definitely don't understand about Haskell.next. Okay, we'll talk about version. Looks like the right one, right? So let's try Cabal build from inside and let's see what it does with its cache. It looks like it just considered that some extra doc test has changed. So no, it goes for the whole build. So let's see if it chokes on the same spot. It does. And it is 8.10.4. Oh boy. It is template Haskell. Same cabal. Probably doesn't matter whether Albion is installed or not. Let's see if there's something about Haskell.mix and template Haskell. Cross compilation planning to make the Haskell work with cross compiling. Haskell.mix will automatically use QEMU to emulate the target when necessary to run template Haskell splices. Yeah, I remember about that. Break singletons. Sec for utiliser template Haskell. There's some issues with template Haskell. So the fact that it has this infrastructure for cross-compiling, does it mean that we need to specify something to that maybe the default is a bit intrusive with regard to template Haskell? Let's do a template Haskell here. Dash. Nope. Nope. Yeah, template Haskell splices. Search again. And GitHub. Some patches here and there for template Haskell. Use host template Haskell equal false. JCJS though. Using iServe, I remember hearing about that. But that is all. Can we deactivate that? iServe. If this is what's happening, how would we even know? The Haskell quote true. Oh. Hold on. Do I need to say this? Do I need to sort of patch accelerate to say that it uses template Haskell? Okay, it could be. So that would be something like packages dot accelerate dot components dot library dot flags. Pin. Oh, it's doing mixed tools. Oh, there was a thing for that. I was looking for that the other time, and I missed it. Adding a new version. Templates. Never used that. Cross-population plumbing. Troubleshooting. It does actually. The kebab build does work. Compiler version agrees. Package index state. Yeah, the packages do come from the snapshot, so it should be fine. And Nix only configuration option. Profiling true in kebab.project. I try to do the configuration in kebab stack configuration. Yeah. File missing. Yeah, none of that. Right, that's what I wanted to take a look at. Template. Have flags. It's not configure flags, I don't think. Test flags. Mail flags. Yeah, that seems wrong. So where are these come from a package? I'm not even sure whether that what that template Haskell flag is. We get template Haskell 21400. we check which package version we would get? List matching a search string or info template Haskell. Version installed to 16. Versions installed to 16. So not that then. Documentation not installed. It really feels like a template Haskell issue, doesn't it? The fact that Haskell.nix has some trouble with template Haskell also makes it feel like a candidate, doesn't it? Shall we just try this and Nix develop and see if the build goes further? That would completely put the blame on template Haskell. There you go. It did go further. So bang. Yeah, I bet you there's something going on with that template Haskell, QEMU, iServe infrastructure. Since IOHK is using this by default, it could be that it's activated by default, but it maybe doesn't support all of template Haskell. And so we might need to just deactivate it manually. Template Haskell has also 32 issues. Customs, ad hoc, ignore versions, packages that come with GC. That sounds like it would make a lot of sense. Just use the one from GC. Non-reinstallable packages. Kind of like this idea. So what? That's just a module. Okay, let's try that. Boom. let's get rid of that. Okay. Retriggers a bunch of stuff. Still the same error. Setting this info from IRC. That I suppose is another way to fix it. Interesting. I suppose it would make sense that it would mean rebuilding a whole bunch of base stuff, since we're rebuilding without any of the Haskell.nix provided built for that. I mean, my thinking is it's a complex interaction between Cabal, template Haskell, and GHC somehow, and that minimizing the things that are rebuilt might help. Oh, hey Joseph, sorry I didn't see your message. Nice to see you. Well, yeah, things are coming along nicely. I've done 3 days on some of like GStreamer Haskell related things, and now I'm back on doing this week focusing on the NBody problem again and CUDA programming. So and as has been often the case in the past month since I've switched to NixOS, I've just doing a bunch of Nix before being able to do a bunch of Haskell. So yeah, that's where I'm at. And I'm also streaming way longer than I should. So I'm starting to feel like I should at least get a little bit of something to drink while things recompile for the nth time. So I'll be right back. Okay, let's get our build from here. I'm curious where it's going to start from. Same place and same error, so this didn't fix it. What's the end like? Yeah, I suppose we could be missing something from our environment as well. That would be a possibility, right? Missing some system dependency. It does seem a little bit unlikely, though. But let's double check. Are we supposed to have a system dependency here without the backend installed with the additional component, documentation, the examples? But lol. Mail map. Yeah. Override the architectures. Yeah, we don't really care about that, I don't think. What else could be? I mean, yeah, basically that would be it, right? That would be the Cabal sandbox, the Nix sandbox model. That would mean that we're missing something somehow. I suppose we need like a debug, maybe a debug version of GHC to be able to know where this goes. How do I know what my current config is? And then the presence of a sandbox, that is Cabal's own sandbox. I think that stuff is default. User global Cabal configuration. Yes, user config. Okay. Edit diff or update. Is that it? Okay, so yes, so you're saying it's in here, and yeah, in fact, there's quite a bunch of stuff in there. And none of that would be available in the Nix develops context, right? What does user config yield here? Or help user config? It says that it was the same, which by the way breaks the Nix sandbox model, if that's really the case. Let's do diff. Not very interesting. So So I suppose I could run Cabal with a kind of verbose mode and then compare the outputs. So I would probably want to clean and then build with some v3 minus v3 and pipe that to some sysbuild.log or something. And then here do next develop. I will go into the same. You go into the same directory, so I actually can't do that. I have to wait. The yeah, the template Haskell stuff. It's built as 40. Data accelerate type get built right there. Doesn't really give any more detail, right? But maybe the context will be useful. Probably will be. Yeah, I'm actually getting AHC to HS, some of the preprocessor stuff from my profile, my user profile. So it really could be that that's actually enough, but let's let it finish. It could be the package list, the Cabal index that was after all listed as one of the potential troubleshooting package index states. Oh, I could pin that. Haskell.next will use the latest one it knows about from package.next. Yeah, so that would be that would definitely be a source of difference. I should have taken this a bit more seriously, but I am taking it seriously now. So do we have a Cabal project here? We do not. But it's recommended we do, which makes sense. But in our case, we do want, okay, it's built. Where we want is basically the 31 days old Cabal build, depending on what we actually get here. We'll clean again, or we'll just clean, and then we'll call this the next build. And we shall select for compare and compare. and check out what this gives us. Finds an 8.10. Index state in fact uses the same, so unfortunately that ain't gonna be where we want the yeah. So okay, let's see. There's some differences here or not. Here, vector. Oh, so hold on, wouldn't that be a consequence of the index? No, he wouldn't. Oh, yeah, no, he would, because he would use stack as the source, but stack doesn't say anything apart from the LTS. So it could be that just Cabal is just a better resolver. So in this case, well, I hate to do that, but I think I'm gonna have to do that. And then let's say just I wouldn't use stack. I'll just Cabal. And I'm going to actually try this up there as well. Up there it feels more tricky because there's quite a lot more that's pinned. So, and we actually well, we could pin it also in the Cabal project. Okay, actually just it worked right away for some reason. I mean, I suppose it was supposed to be in cache, and error. Yeah. So we delete the stack.yaml. Okay, there's a bunch of stuff, and we try and do the same thing here. We try and move this into like about the project. Extra packages. Should be considered local packages, not implemented. So that's not it. It's just in packages, I think. Then I don't know if we can. There's a way to specify bounds. Oh, but of course, there's a way to specify bounds which is in the cabal file. Right, so this should already be done. So let's not bother. And yeah, let's rename this dot back, and then let's I need to commit that, I think. Stack.yaml and stack.yaml.back. And then we'll need to mix them up, and we'll need the compiler name. All right, and we're ready here. And come on. Ah, damn it. Didn't work. Okay, so let's clean, clean, and then recreate a build log. And oh yeah, we're going to need to compare those. So you didn't append, right? I hope you didn't. Let's select for compare. Compare is selected. And get back to it. It's processing the diff. Yeah, so that stuff's not gonna work, but hey, in any case, I think getting rid of stack is probably the correct move. That's the move I feel inclined to do. Okay, so that sounds good. And then we still have that oh no, we seem to be picking up very similar ones now. 0.12.20, 2.13. It's just that these have a hash because they're being fetched by Nix. Unix 2.7.2. So all of these, yeah, they look right. It's interesting. It's yeah, that must be the famous kind of patching of the GHC package database. So it makes comparison of the version numbers harder, but 222, 222 seems like all consistent. And that's cool. It gives us the plus bound checks, minus unsafe checks, minus internal check. I think that's the same thing we have. And then it does all of the upstream dependency, at least for the setup phase, it looks like. GHC boot TH810.4. Do we have that here? GHC boot TH810.4, we do. And then elaborates the install plan. And then then very different for some reason. Components. I did minus v3, but for some reason it only catches up right here. So my system build, yeah, it kind of makes sense. Does it? It sees all of the stuff that that I suppose it found, or it solved for in the build plan, and it lists them, but it doesn't do that in the next case. I don't know why. It's maybe just assumed to be correct in the with the next dependencies. But for accelerate, surely is the case, but it would mean that everything that's kind of template Haskell and whatnot, it would come from somewhere else. Do we have any of that in that green bit? We do. We have that at 2.16.00 here. I suppose we have the same version. However, we've only seen 2.16 installed, 2.16.00 installed so far. And we do. So here it seems like we only have hash differences, and that in fact all of the version numbers are the same. Interesting. So so I think this was the was this the configure phase right there? Not really. Not sure what you call this phase. But for some reason, you think these are pre-existing, whereas here they're seen as configured. Doc test is a slightly different version. Is that and what's up with exceptions? How come we don't put it in? That's a bit weird. Why would that? In fact, it's kind of the other way around. Like, exceptions are in the Nix build, but not in the system build. So are these like transitive dependencies, and that somehow they've been flattened here? I think that's probably the case. Exceptions. Yep, here it is. It's included here as a hedgehog dependency, for instance, but also as a concurrent output dependency, but it's not a direct dependency of accelerate, but it's been made so. But in contrast, I mean, there's slightly different versions here. I didn't see that this patch Semver value is actually different here for hedgehog. So the resolution here is obviously different. And our hedgehog appears here. Okay, hold on. What? Hedgehog not here. That's for component and unit, and it's not here either. And neither is exception. And also there's a bunch of them that are not there. Well, I'm not reading this correctly at all. Yeah, it's not only the version numbers that change at all. It's just that there's a whole bunch of stuff that is included in the accelerate build and that is not in the Nix build. That's in the system build, but not in the Nix build. Why? Plus it's a different version number, so those are definitely of interest as we try to troubleshoot this. Like, would we want to pin something different? 8.10.4, would we want to pin 2009 instead of unstable? I mean, I suppose it's worth a shot, right? What I mean, the worst that can happen is that we recompile, because that seems to always be the case. But input next packages follow. That's the unstable thing. But if we want to follow open a shell for use for stack. I see. Huh. I actually didn't consider that. Would that well, wouldn't that be nice if it just worked? But I removed the stack that oh no, I didn't. I just renamed it. Okay, so let's backtrack and try to try to do that, and then let's next develop again, except, and that's the last thing we'll try, because we've been flailing at this and it's not the best. Right, yeah, this is just going to fail on the accelerate compilation. Why would it not? Okay, so last thing then, I just want to know how to do input next packages follow with the stable release, and then we'll leave it at that. Next packages, that's it. NixOS 2009, that's the syntax. Although it could be a different syntax for Haskell.next. But at least we're trying something different, so we're not madman, you know, trying always the same thing, expecting different results, as the saying goes. I don't know how exactly the saying goes. Let's call that next. Is that going to be tags, branches, releases? Follows. Expected unstable. That's the getting started instructions. I suppose we could try this. Fake input. Can we list things? Nixflake something. Info. Haskell next. Nixflake has registry, right? Okay, how list flake inputs. How do we show the registries? Registry. List. And so when we say Haskell next, we mean this. Is that right? I don't understand how follows work. Okay, let's go back to this last time. And well, maybe default. If it's that follows, PKG is unstable. That's not the same as Nix package is unstable. So it says Nix package is unstable. Maybe it's in the flake then. Ah, yeah, probably is. 2009, that's it. And so that's in the inputs. Okay. That's it, right? Yeah. I mean, it's a weird thing to try because I believe my NixOS config is following unstable, but it's a little bit weird. It's actually in flake. The main one is 2009, and I have unstable loaded. So yeah, no, I guess the main one is 2009. So maybe that's the way to go. Except that there's no such thing as this particular driver here. Sadly. I think this is the right version, right? And so Linux packages and NVIDIA X11 NVIDIA packages. I think that's where, whoopsie, that's where things are. But we don't have the one we want. That is not good. The X11 one, via BL. Don't know what BL is. Well, I mean, we could. It's kind of okay if we didn't have Vulkan, but I do need to check which version that's around, because otherwise that's going to cause us some problem. Change path. Next package latest. NVIDIA package Vulkan beta, but we don't have that, right? Four, 5. So 455, yeah, is not evidently anywhere here. So we might just have to just go for this one. I dislike this, but I'm worried it might break something. Let's just go for this one. And I suppose I could also try and log the environment here and log the environment here, because those are also worthy, I think, of being examined. Okay, log, select for comparison, and log. Compare selected. Bunch of host path. The LD has this telepathy thing. What is this telepathy thing, by the way? It's LD library telepathy. Because there's a telepathy logger. Yeah, telepathy logger. Where's that? Real-time communication. Maybe GNOME installs this. I don't like that this is turned on by default. Okay. GCC. We did try with that, with those GHC options, but I suppose maybe not for when doing the Cabal build here. The one, the LVM HS one, but we don't depend on the LVM here, so no, that's not relevant. Where are we with this? Yeah, it's rebuilding the world again, I guess, as expected. And I was comparing the env. So I thought maybe something about the C compiler. That sounds possible, right? 10.2 here, and let's go outside here. Oh, 10.2 here as well. PWD, it's actually the same. Mixed path, we don't really care. XDG shouldn't matter. NixCC, so yeah. Numa. There's a bunch of stuff. I suppose maybe I should wrap total word wrap here, because some stuff is going to be hard to see, like like all of that stuff. So I mean, could it be like a different version of make or core utils? It's possible, huh? It is possible. Which would potentially be something that we actually get back to a more stable version, which would sort of fit the narrative of, because we're sort of too ahead in the Nix develop environment, using unstable for everything. That's why we're breaking. I kind of like that sort of overarching explanation. Right, so those are all the things that are just made available as Nix store available packages instead of Cabal dependencies, or as Cabal dependencies but that are built by Nix, in fact. Ranlib, not sure what that is. GI type lib. Oh, I see. I didn't. It's a bit random that it doesn't take a word wrap on both. XDG. GI type lib is actually the same. Upper dump, some flags. GIU is the same. Temporary directory. For some reason, allows an impure Nix shell. Not sure why. I would have thought that Nix develop. I suppose maybe being in the shell by definition means impure because you can side effect your way into anything in there, maybe. LD flags, locale. I mean, sometimes locale create weird low-level compilation problems. Next packages, user path. Next build top. Info path. Yeah. I suppose LD could potentially be different. That's from core utils. What actually GNU bin utils? Is that the same as core utils? Don't know. But it's the same one. Cabal user config didn't give us a lot of details. Yeah, this is kind of rebuilding the world again. Okay, well, that's where I'll let go. It took me a while to let go, right? It's 11. I'm already an hour and 40 minutes over. But I usually, you know, reasonably assign to myself as streaming time. But yeah, that's how it is. Sometimes you just want, I mean, for me at least, I want to try to, you know, solve the problem. Try this one more thing that maybe is going to solve it. But we didn't solve it. There's we can build, we can specifically Cabal build outside of next develop. Let's be more specific. We can Cabal build the accelerate library outside of next develop, but inside it fails with that error. Yeah. 10.2, and yeah, we need to troubleshoot this. We did move from did we? We're moving back and forth, like moving back and forth between a Haskell.mix Cabal project or stack project, which I don't know if it's a good thing, but we're doing it, and it's means that means I suppose that's part of our troubleshooting, right? And here, that last thing we're trying is we're trying to build with a not in accelerate but in accelerate examples, we're trying to build with the Nix packages following a stable release instead of unstable. So that's, I suppose, is one of our current troubleshooting attempts. Trying to build accelerate examples with this. Okay, now I kind of want to wait until this is done. It'd be nice if it just worked. Yeah, I'm gonna wait for it. Yeah, if we compare these things, it seems that that would be one potential area, right? Like this would be caught from unstable, I think. Maybe. And so all of these I mean, the thing that's weird is I think they are not gotten directly from upstream Nix packages, but they might be. I thought that maybe Haskell.nix actually sort of rebuilt them, but it seems like too much work. It seems like maybe they're just pinning different ones and whatnot, and allowing to override the pinning more importantly. But I suppose that as wholesale, they might be just pointing to the ones that are in Nix packages. So in that case, it is quite significant to move Nix packages from one version to the other. We don't see a lot of big differences, but it could be a small difference, right? It could be a bug that's just introduced with something fairly recent. I want to look at template Haskell again. It's just 2.16.0, right? But and it feels a bit like, well, no, I was gonna say it feels like Cabal, like Haskell.nix should, no, that Cabal should use its index to build stuff, but in the case of Haskell.nix, it does, but only the stuff that's not built by Haskell.nix itself. So there is room for this to fix it, and it didn't. All right. So we know it didn't work. That's a bummer. But such it is. We end on a bit of a cliffhanger note, as we often do, and we'll get to solving this on the next stream on Thursday. So thanks a lot for watching, and I'll see you later. Bye-bye.